Hi there. Well, what we're going to look at are some special cases of factoring. And one of them is the perfect square trinomial, and the other is the difference of squares. And if you can recognize these, it kind of shortens the factoring process if you can. Now, the first one we're going to talk about is the perfect square trinomials. And here are some formulas, but we're going to be looking at some formulas for the difference in sum of two cubes in the next section, and you will have to memorize those. So to me, this is just something extra to memorize, and it's not necessary. If you've already memorized them in your previous math classes, that's fine, but you really don't need to know this in order to factor using a perfect square trinomial. All right, but we're going to come back and look at these to see how they work a little bit, but it's really not necessary. Okay, a perfect square trinomial. Going back, what's going to happen is given this polynomial, either one, our answers are going to look like this. And I'll show you why and how to do that through the examples. But this is our ultimate goal. Given a polynomial, do some of them look like this after they've been factored? And what does it mean, the squared here? Okay, so let's go ahead and get started. First off, what I do is always look for the greatest common factor in your polynomial. And this first one, there is nothing in common that can be taken out. And there's not a common variable, so you don't have that. It is in descending order. You've got the highest power, and then x to the first, and then no variable here. So we're good there. So what I do is when you look at the number 25, all right, and if something times itself will give you 25, when I set up my parentheses, okay, the first times the first, I always try that first. So, so like if you had 36, I would put 6 and 6 here and see if it worked. If you have 49, I'd put 7 and 7 there to see if it worked. So I always try that first. And again, 5 times 5 multiplied gives you 25. And it just so happens that when you add them together, you do get 10. So this will work. So we've got 5 times 5 is 25. Everything's plus because all those are plus. Now let's see if you get the 10. 5x and 5x. When you add those, you get the 10x. So you set it up again with the first and the last, and then you check it with the middle. And so this works. So you've got x plus 5 and then x plus 5. Now, rewriting this, because I have two that match, it's written as x plus 5 squared. All right, so that's why on these we have the squared, so that when you factor a polynomial, okay, if those match, you write it like this. What does that mean for the solution? If I have an equals 0 here, if I were to find the zeros, the solution, the roots, the x-intercepts, all those mean the same thing. Because these match, I just use one of them and solve it. Now -5. So you only use one of them. It's called a double root, but you don't need to know that, maybe for future. So the answer is just x equals 5, if it were an equal sign. All righty. Okay, let's look at B. So if we were to rearrange these here in order, we'd have 3x squared plus 4x plus 16. Okay, now if you look here, which of the following are perfect square trinomials? Could I get this to look like this right here? Well, In order to do that, it's not that you can't factor this, it just won't look like these. These two won't match. And the reason is, okay, 4 times 4 gives you 16. Actually, I haven't even tried to factor this. 4 times 4 gives you 16, but you'd have to have a 3x times an x to give you that. So no, you could not make this look like a double here, like we did in the last one, because of this right here. And this really actually cannot be factored. This actually would be a prime. If you were to try the different combinations, if you were to ask to factor this, you know, we haven't really talked about primes much. If you were to try 4 and 4 and everything's plus, you get the first term, set it up, get the last term, it's part of the setup. Do you get 4x? 12x and 4x is 16x. You don't get 4x. And even if you tried 16 and 1, you're still not going to get 4x. So in this case, it's prime, and it's also it's not a perfect square trinomial. All righty. Now the last one, is that a perfect square trinomial? So here we have to rearrange it. Could we, is there a possibility that this could look like these where they match? Well, let's look. What gives you the first term? 10y times 10y. Ooh, those do match. What gives you the last term? 9 times 9. We're just kind of seeing, could it, you know, do we have a perfect square trinomial? And there is a possibility to have a perfect square trinomial. Let's go ahead and try it and see. We have 10y and 10y. Remember, to be a perfect square trinomial, these guys have to match. 9 times 9. Okay, now, do we want pluses or minuses in there? Well, I do know that the signs have to be the same, because when I take the last times the last, to get a positive, they have to be the same. But when I'm combining those, that OI, I need it to be negative. So we'll make them both negative. A negative times a negative is a positive. Let's see if we get the negative 180. You know, and so if you can recognize that something times something gives you this, something times something itself gives you this. All right, and then try this and see if you get the middle term. Otherwise, I mean, this would be a nightmare. You'd have to, you know, 50 times 2, I don't know, 25 times 4. I mean, it's endless. So you're hoping that this does work. And chances are, if something times itself gives you this and something times itself gives you this, this is going to be the factoring of that. And then again, I forgot to say, oh, let's check for the greatest common factor. There isn't one that goes into all 3 of these, but don't forget it. Don't forget to do that. All right, so we set it up with the first and the last, and now let's see if we get the middle. So that's a negative 90y. Negative 90y, when I multiply and multiply, combine those, I get a negative 180y. So our solution is 10y minus 9 squared. Comes up with that. So just sorry. Okay, so this is how we would write the solution, or the factoring. If you were trying to find the solution, you just use one of those. If they match, just use one of them. Okay, all right, let's look at another one. You can always, so, I mean, and again, you can always use the Xbox method for this. This just might shorten it if you can try something, especially something like this, to try it first to see if it works. It could shorten the process. All righty. X times X gives me that. 5 times 5 gives me that. So we can see if we're going to get a perfect square trinomial. Set it up. X times X. 5 times 5. And they both have to match and they're both negative. Do you get a minus 10x? Minus 5x and a minus 5x is a minus 10x. So your solution is x minus 5 squared. Perfect. All right, let's try another one. Doesn't look at this. Well, I'm going to go ahead and rearrange it here in the right order before we look for a greatest common factor. Okay. So here you look for what's in common. There's nothing in common because now that it's in the right order. So looking at this, could it be a perfect square trinomial? Is that something I should try first? This right here is 4y times 4y, gives you 16y squared. 7 times 7 gives you 49. So good, let's try it. See if we get the middle term without using the formulas. 4y times 4y, 7 times 7, everything is positive. Everything is positive up here. Okay, let's see if we get the middle term. 28y, 28y. When you multiply, combine, you get 56y. So you're done. 4y plus 7 squared. It means you have 2 of these. Now, if you wanted to go back, if I gave you this and asked you to multiply, make sure you rewrite it like this. Multiply it to get this. All right, so again, it's kind of a little bit of a review that if you've got a squared, rewrite it to go backwards to the polynomial. All right, let's look at the next one. Well, I've got x's and y's. It's all right. I'm going to put them in order. Well, what goes first? The y squared or the x squared? I recommend you put the x squared first. Oops, forgot the 5. And then we put the xy next. So we have x squared, x to the first, and then no x. That's kind of how you think of that as far as the order goes. X squared, x to the first, and then no x. Could this be a perfect square polynomial? No, 20, not 2. I'm about to say, we're in trouble. There, perfect. All righty, so we have 5x times 5x. 2y times 2y. Chances are it's going to work. So I put my 5x and 5x, 2y and 2y. It looks like the signs have to be the same, but when I'm adding them, I'm getting a negative, so we'll make them both negative. Let's check it and see if we get a minus 20xy, and if we do, we're done. So this right here is a minus 10xy. This right here is a minus 10xy, a minus 20xy. Perfect. So we rewrite it like this. These two statements mean the same thing. All righty. Let's go ahead and try another one. This one. We're going to rearrange this one in order. So we're going to put this first. Then the y to the 5th goes next. And then a minus 4y squared goes next. All righty. So here we'll go ahead and take out the greatest common factor. Well, 4 goes into all 3 of these numbers. That's the largest number. Just always try the smaller number to see if it'll all go in evenly. And I'm going to take out a -4 because I want my leading coefficient to be positive. So I'm going to take out a -4. They also have variables in common. So I will take out a y². Okay. So there's my greatest common factor. A negative because the leading coefficient was negative, and inside I don't want that. And they all had a y, and the smallest is y². So let's go ahead. This divided by this is a positive 36 y to the 6th, because you're subtracting exponents. Multiply it. Add exponents when you're multiplying and come back to the original. All right, 48 divided by a -4 is a -12 y cubed. You're probably thinking, wow, this is interesting. So again, multiply a negative times a negative is a positive. So you'll have a positive 48, add exponents to the 5th. This -4y² divided by a -4y² is a positive 1. All right. Okay, let's see if we can factor what's left in the parentheses. Is that possible? Well, let's see if it does the perfect square trinomial here, because I know that 6 times 6 gives me this. So 6y cubed times 6y cubed will give me that, 36y to the 6th. Remembering that you add exponents when you multiply. So those match. It's a possibility. 1 times 1 gives me 1. So let's set it up with those, see if we get the middle term, and then we can be done. If not, we'd have to go back to the 36 and try something else. There's nothing different here, but you could do 12 times 3, 9 times 4. But we're going to try this first. If there's something times itself that'll give you that number, try it. So -y² in front. Don't forget to bring that down. It's part of it. Don't forget to do that. All right, so we're going to try 6y cubed to give me the first term. 1 times 1 gives me the last term. And I want them to be the same and negative. Let's see if we get a -12y cubed. -6y cubed, -6y cubed. When I multiply and multiply, -12y cubed. So how would I write this? I'll just come over here. -4y² on the outside, 6y cubed -1 squared. That's how you would write the final answer. All righty. Okay, let's look at solving. We kind of already done one of those. When you're asked to solve, first off, you have to have a 0 on the right-hand side. You have to have a 0. I mean, there's going to come a time in later chapters where we won't do that, but for right now, bring it over. There are circumstances. Add 16. So that's gone. And they're in the right order. Look for the greatest common factor. 4 goes into all of these coefficients here. So I'll divide it by 4. No variable because the 16 does not have a variable. This divided by this is a². Multiply it to check it. Yes. -16 divided by 4 is a -4a. Multiply, comes back. 16 divided by 4 is 4. So now we're going to check, now we're going to factor what's left inside. So a times a gives us this. 2 times 2 gives us the 4. So let's try it. Otherwise, you could always do 4 and 1. We're going to do the 2 and 2 first. They're the same sign and they're negative. Do you get the middle term? If not, rearrange it. Minus 2a and a minus 2a is a minus 4a. So it looks like we factored it correctly. So we've got a, and we're asked to solve it now. All right, in order to solve it, 4 has no variable with it. So it has no part in making this 0, just these two. All righty, so unless there's a variable, if there's a variable out there, a equals 0 would have been an answer. So any variable gives you a 0 for an answer, but there is no variable. 4 itself will never be 0, 4 by itself. So now we just take one of these, since they match, and solve it. Add 2. And there's your solution, a equals 2. All righty. So because it's a double root, when I say it's an x-intercept, I'll just kind of give you a little picture of this. It means that it touches at the 2. It's a parabola. All right. So when you've got when you have what's called a double root or anything, if you have an even number power here, like a 2, if you had 4 of these, it just touches. It doesn't cross, but it is an x-intercept. It's an x-intercept or an intercept. Okay. So that's enough of the perfect square trinomial. We're going to look at another one. Move this down a little bit so you can see the top. It's called a difference of 2 squares. Now, what happens with a difference of 2 squares, these match except for their signs. And we found out that when you multiply these using your FOIL, the first times the first is 4x squared. I'm going to move it down just a bit so I can do my smiley thing here. Okay, 2x times 2x is 4x, 10x, and a negative 10x is 0. There is no middle term. The last times the last is a minus 25. Okay, so if you notice that if you're given a polynomial that's lacking the middle term, that x term, that x to the first term, chances are it will look like this when you factor it. They'll match, and you'll have to have a plus or a minus. Notice that you have to have a negative here. You have to have a negative here. Something times itself has to be this term. Something times itself has to be that term. And if that's true, your answers will look like this. Okay, so does it fit? See, here's kind of a basic formula. So something times itself, and a difference. It has to be a subtraction. Your answers will look like this. Well, where these will match, they'll just have opposite signs. So let's go ahead and determine whether each of the following is a difference. Let's just determine that. Some of these are tricky. So we have 3x times 3x gives you this. 8 times 8 gives you this, and it's a difference. So it's a yes. It would actually look like 3x, 3x, 8, 8, plus, minus. You're done factoring. And then you could set each of those equal to 0 to solve it. Okay, let's look at this one right here. The first term, 5 times 5, but this is a cubed. So you'd have to have a t squared times a t, which does not match. So this is a no. The form of the factoring would not look like this. We do have a way to factor that, which we're going to talk about in the next video. Well, except for this number, it's going to have to change a little bit. Okay, let's look at the next one. Okay, you can rearrange these. Okay, you can make it look like that. And you're thinking, well, the leading coefficient isn't positive. In these cases, when you're missing that middle term, it doesn't need to be. You can rewrite it like this. All right, when you're missing that middle term, when you just have 2 and a subtraction, I would write it like this. So we have an exception. Bummer. Now, what gives you 36? 6 times 6. What gives you 4x to the 10th? Excuse me, not a 4, a 2. X to the 5th times 2x to the 5th. Again, when you're multiplying, you add exponents. So to come up, you just divide that by two parts and tell you what that is. So this one could be factored. Actually, it is a difference of 2 squares. Well, yeah, I forgot to take out the greatest monomial factor. So let's do that. If I were to take out the greatest monomial factor, it would be 4. 9 minus x to the 10th. You would, if you were solving this, if you did it this way, you would have gotten the right answer. But if we're asked to factor it, Pearson would have kicked that out because I forgot to look for the greatest monomial factor. So now, can the rest of this, 3 times 3, x to the 5th times x to the 5th. And yes, it can. So you have a 3 and a 3, x to the 5th, x to the 5th. It doesn't matter where you put the minus and the plus. Okay. So ignore that right there and factor out a 4. I forgot to factor out the 4. All right, let's do some more examples. And again, not going to forget, factor out the greatest monomial factor here, greatest common factor, 5. 5 goes into both of those. So you've got 5 divided by 5 is 1. If you multiply, go back to the original. Here the 5's canceled, x squared, y squared. Now, it's a difference, so we're good there. If it's a plus, well, here, we'll finish this one and I'll do one with a plus because I don't see one as an example here. So we'll do one as a plus. Okay, now 1 times 1 gives you 1. They match. xy times xy gives you x squared, y squared. Because when you multiply these, you add exponents. 1 plus 1 is 2. 1 plus 1 is 2. Minus plus. And you're done. Let's look at the next one. We've got 144 minus 9x squared. Well, does 9 go into both of these? Look, going way back to your division rules, if you add the digits and the sum is divisible by 9, then this number is divisible by 9, which is kind of an interesting fact. But 4 plus 4 is 8, plus 1 is 9. So I know 9 goes into here evenly, looking for the greatest common factor. So 9 times 144 divided by 9 is 16. Minus 9 divided by 9 is 1x squared. We have a difference of 2 squares because 4 times 4 is this, x times x is this. 4 times 4 is 16. X times x is x squared minus plus, or plus minus. The order doesn't matter. And you'll notice that you will not get a middle term with your OI. positive 4x and a negative 4x is 0. Awesome. Let's do C. Pull out the greatest common factor. So we pull out a y. There's nothing that goes into 16 and 81 because 81 is just 9 times 9 and there's no 3's or anything in a 16. So you have y, we have 16x to the 4th because the y's would cancel. If you multiply back to the original, and then this would just be 81. Y times 81 is 81. Go back to the original. Is this a difference of 2 squares? Yes. 4x squared, 9 and 9. So here we go. To factor it. 4x squared. 4x squared minus 9 plus 9. And there's your factoring. Okay, now what happens if I have a plus? If I had 9 plus x squared, all right, this is prime. What that means is that if you were to graph this, there's no x-intercept. If you were to graph this, it's above the x-axis. So there's no x-intercept, there's no solution, there's no root, there's no 0. All right, because even though 3 times 3 and x times x, it's a sum. So again, make sure that you can recognize the fact that that's prime. It cannot be factored. And that's where we come into imaginary numbers later on, as to how to solve that. Okay, what we're going to practice now is we're going to go and factor completely. We're going to, I don't know, some of these may not be a difference of 2 squares, but it's also a review of when we have 4 terms, how do you factor that? Given the 4 terms, we're going to group. So we'll have x cubed plus 3x squared. But when I group this next one, I have 4x plus 12. Okay, when I group that. All righty. So here, I will pull out the greatest common factor of an x squared. If you're grouping, you'll always be pulling out a greatest common factor. X times x squared is x cubed plus 3. Minus, let's pull out a 4. So this divided by this gives me x. 12 divided by 4 gives me 3. Got to watch the signs there. So here, if you multiply this, you have to come back to the original. So this times this is a minus 4x. This times this is a minus 12. So just watch that and double check and make sure you've done it right so that you come back to the original. Okay. Okay. Yeah. Now we're going to take out what's in common. Trying to think of different ways to explain that sign. But I'm going to take out an x plus 3. What does that leave me with? In the first group, it leaves me with an x squared. In the second group, it leaves me with a minus 4. Well, if you stop here, Pearson will count it wrong because this can be factored. It's a difference of 2 squares. X times x gives you x squared. 2 times 2 gives you 4 minus plus. So that is the final answer. So make sure you're done factoring when you do these. Okay. All righty. Let's go ahead and try another one. Oh, now we're going to solve. If we solve, you have to move everything over and put it in descending order. So you have to set it equal to 0. And a minus 8. So I'm moving those to the other side. And I wanted the leading coefficient to stay positive. That's why I didn't move it over here. So we have 27x cubed plus 18x squared minus 12x minus 8 equals 0. Okay, let's group. Let's group these. And we'll just do these. Go like this, go like this. And so we'll have a plus in the middle. 27x cubed plus 18x squared minus 12x. That's going to stay positive. All right, factor out what's in common. Here, it looks like it'll be 9x squared. This divided by this is 3x. This divided by that is 2. If you multiply, you come back to the original. Now here, I'm going to pull out a 4. That leaves me with 3x plus 2. If I multiply, I come back to the original, including the signs. All righty, let's take out a 3x plus 2. And I'm left with a 9x squared minus 4. There's going to come a time where you could actually solve it from here, but we're going to keep factoring. Until later in chapters. 3x times 3x. So again, this can be factored. It's a difference of 2 squared. 2 times 2 gives you 4. 1 has to be plus and 1 minus. Interesting. Okay, so now what are my solutions? Well, these match right here. These match. So I only have to do one of those. One of those, as far as setting it equal to 0 and finding out when would these be 0 and when would that one be 0. One of them, one of them has to be 0. So you subtract 2, divide by 3. So there's an x-intercept, negative 2/3. Over here, add 2, divide by 3. X equals positive 2/3. And there's your other solution. Okay, you only have to do, if they match, you only have to do one of them. So, all right, those are my two solutions, negative 2/3 and 2/3. Because this is what we call a double root, it means it's going to touch the x-axis and it's going to cross the x-axis at positive 2/3. All righty. Okay, well, what we're going to do is we're just going to go ahead and go on to the last one, because this one's exactly like the others up above. You know, you just group them and then factor it out. Just don't forget, a common thing to do with these is do not forget to finish. And also with this one, oops, excuse me. So again, we factored something out. Always look, am I done? And in this case, you were not. Here, always ask yourself when you pull out, is this done? And then if not, continue factoring those once you've pulled out your greatest common factor. Now, looking at the last one, find the zeros of the function. What does this mean? You take the function and you set it equal to 0. That's what that means. We're going to factor. Greatest common factor is a 2. And then we'll factor what's left here inside. It looks like x times x gives you x squared. 1 times 1 gives you 1, and it looks like everything's a plus. Let's see if we get our middle term. 1x and 1x is 2x, so it does work. How do we solve this? This outside term has no variable, so you ignore it when you're solving. Both of these are the same, so it looks like we'll have only one solution here. Just subtract 1, this double root they call it. And there's your answer, x equals a -1. So again, this outside has to have a variable with it in order for you to have an x equals 0 solution. All righty. Well, that pretty much does it for this section. Good luck, and let me know if some of this was very confusing and you need some extra help. I'd be happy to. All right, bye-bye.